thanks for Reaktor for this great opportunity. It was our intention to just have a 15-minute briefing about our little Ethereum application project, which has an educational purpose. Unfortunately, Mikko wasn't able to join us tonight. But he had studied solidity in detail. He works in CGI financing. And my domain is application development, and I knew solidity and blockchain in a more shallow way. So we decided to go together and to build a full stack demo application so that we could just learn what comes there, and then create some guidelines and perhaps even some kind of framework how to build a complete application which uses Ethereum. So our aim was first to face the real life problems, to articulate them, make blog posts, and these are the problems that that arise when we develop this application compared with like ordinary or mainstream applications. And this is how programming a blockchain application is different from, for example, programming a database, a traditional database application. And to provide solutions, maybe not the best solution, but some solutions and guidelines. We are just in the beginning of this path, so our demo application is unfortunately it's not just quite yet up and running. It was my intention to get there are all components are tested separately and they work, and it was my intention this weekend to put them, the last weekend, to put them together, but my body temperature reached nearly the 39, probably not for that reason, but anyway, and my wife told me not to code, so it's I'm frustrated. Okay. That time she was right, yeah. Our demo application will be called Servit. It is meant to be like a common Ethereum application, if one can say that there is such a thing in the world. But anyway, a peer-to-peer application for individuals to exchange services, that I can sell your cleaning and you can sell me car painting, and so that the people can make such deals. Sorry. The idea that it would work in the public Ethereum network, or at least this demo version in this Rupsten or other test network. So that's the context of the demo application, but our focus is more on the application structure. See here is one screen copy of the application test version. It is not just yet running, but now, because I don't have the other computer, I have only this one screen copy. People can register there, they can provide services, and they can buy services. And the payment can be, initially it is thought that it is either Ethereum payment or some internal token. But people can make their agreements and deal with complete these deals in this application. It was my idea to put here for these demo purposes a blockchain monitor where you can see all the blockchain activity, what happens there. When we designed this application structure, we faced many quite fundamental questions which arise with Ethereum applications. First question: what to put on blockchain, and what to keep in regular SQL database. Now there can be two extreme approaches. If we want to be fully decentralized and full blockchain, we could try to put there a lot of all the data, but we know that it will be quite expensive. So it really doesn't make sense. Do we need an SQL database in such an application at all? This is a good example of a real life situation that, for example, this information about what services are there available and when and what are the categories of the services and so on and so on. This information does not belong to the blockchain at all. It is just a kind of temporary operational information to make the actual deals possible. And then we can. So there is a lot of varying data which must be still stored in traditional way somewhere. Another question is that whether we should, because this Ethereum and Solidity enables quite rich like class structure, and smart contracts can be arranged as a structure, so, and you can write quite comprehensive data structures using Solidity. So would that be the best way to do? But as we have been warned, they are immutable. So if there are the more there is Solidity code, the more we are in a waterfall thinking, and can make things difficult in the future. So the other extreme would be a minimal approach that just put some hashes to the blockchain and nothing else, a minimal amount of information. So, but on the other hand, too little information then makes the information that it is not maybe in any practical form for many purposes. And then there is this problem how to upgrade smart contracts. We have learned so far that they cannot be upgraded. Well, it is basically it would be possible to make their upgrade feature, but of course that would be legally problematic, because all parties should agree that okay, now we permit this upgrade. But technically it could be done, but difficulties rise elsewhere. And then this application and blockchain interaction, and that is especially my domain that I wanted to study and perhaps provide some solutions. Mikko, who studied solidity, he provided me a quite sophisticated structure for smart contracts. Each rectangle here represents one contract. So there are not just agreements between parties who exchange services, but which is natural that the services are delivered in many parts. So they are also contracts. Also, user is not just a user address; it is a profile contract. And then there was also an authorizations contract that enables through these controller contracts some kind of control to the whole set of agreements. For example, if the owner of this service application changes and there must be a new instance must be authorized to all existing contracts or so. So this is the idea what Mikko provided me. Okay, we build this application using this contract model. Well, I said okay, but I was a little bit thinking that is it really so? Would it be perhaps make sense, for example, just to combine some things like put these deliveries as a list of structs inside agreements, and so on, and not a separate separate contracts. Well, these are exactly, I don't know, this model came from somewhere to Mikko, but this is exactly one of the problems and questions we want to discuss and analyze when building this demo application. What difficulties may arise and what design decisions are found preferable. And my point to this application is this, that how this smart contract deployment and smart contract communication, how the choreography is arranged between blockchain and application. So excuse me. These points are, for example, when I'm building the application that interacts with the user, the web application, I have used here a SPA application which uses a REST interface and can provide user a kind of normal user experience in web interface. My experience is that while the blockchain, everybody says that it is trusted, but from application points of view, it's in a way far away, the blockchain, the Ethereum. My code contacts it, and I can send there something, but then I cannot really trust when the response comes, or how long does it take, does it come at all, or at some moment do I get contact at all. while my familiar SQL database is near and completely reliable to me, but nobody else in the public trusts only that. So I decided that, okay, record everything that happens, prepare to everything, prepare timeouts and for example, timeouts, and that makes actually a lot of code. And now I was thinking that some kind of framework would be necessary. This is perhaps a ridiculous idea to put code in the slide presentation. Maybe you cannot, sorry if it's a little bit small to read, but here is an example. I decided to use the latest Web3 library for Node.js to communicate with Ethereum, and it is very so-called promise intensive. Those who are familiar with JavaScript and especially Node.js know promises. So these are just some points I want to raise. This promise intensive approach is good because it suits the situation where everything is uncertain and you cannot know when answer comes and how many answers are there coming in and so on. So this so-called promise method makes me possible to clearly define functionality for each situation, regardless of when they come, when they occur, or do they occur at all. For example, and then I record everything. If there is an error, I record an error to the log, or success, and then I may use my own parameters to control things. For example, here it reads on confirmation. So this is after a smart contract deployment, or actually for after any other transaction, there comes may come error. There should come transaction hash. There should come receipt. There should come some number of confirmations. This actually it appeared that the Geth test network sends 24 confirmation. I don't know how many there could be, but I just said a constant happy confirmations, which makes it okay. There are now enough confirmations. And if everything is okay, then we are happy so far, and continue to the next step of our sequence. Okay, I think that's quite like that. So this was just an introduction that what we are doing, and we will continue developing on this, and we will continue this blog post, and also I think we will open some GitHub soon, and so that you can, because this has been, for me, this has been just a spare time project. It usually takes more time than expected, but anyway, that's what we are doing, and we would be very happy to share with this you, and if someone wants to contribute, that would be a very great thing too. Okay, I think that's it. Thank you for your time.